And welcome to the Reaction Prediction Lab. Your assignment was to actually take a look at each of the reactants and predict what the products are going to be. Then we go into the second day of lab and we actually physically do these to see what type of reaction is going on and to verify what we predict would be happening. Now in each of these you're going to have to write a full balanced equation and do a reaction type. So classify that type. And so this part is just to verify what we're seeing. You're going to be doing some observations. So the first experiment we're going to be doing is sodium and water. So that's what we're looking at, is just plain old pure distilled water, and we're going to be adding sodium to it. Now, sodium and water can make possibly two different products. It can make sodium oxide or sodium hydroxide. And so we can use litmus paper, we can even use an indicator such as phenolphthalein to tell us if we have some kind of base present. Now when I say base, I mean some kind of hydroxide. Now notice that my beaker is a little bit dirty, so I do have a little bit of weak pink to it. So just to be fair and objective, we have a little bit of a base in this already, probably from some soap that I was using, but we're going to add the sodium to it and see what we get. So I've got some pieces of sodium metal, and we're going to let that go a little bit, and they are coated with an oil. So the oil is hydrophobic, so it's going to actually keep the water away from the contact of there. So I'll give it a little swirl. And then, as soon as that oil has dispersed away from the sodium metal, notice that I start to get a reaction. There we go. And so what's happening is it's reacting so violently that the metal can't even touch the water itself. Now typically if there's no oil on it at all, it won't even sink down into the water. So you'll see the sodium experiment done quite a few times where it just sits on top of the water and floats around and fizzes. So we see that a gas is given off, and now the sodium metal is gone completely. So what are the products? Now we're going to go through the same protocols and do experiments with other substances. So number 2 is calcium added with water. Now again, to be fair, let's go through and verify this. I have phenolphthalein. I'll add in a couple drops. There we go. Did not turn pink this time because I have a nice and clean test tube. And I'm going to add just a small amount of calcium metal. Now you see that it's going to be reacting with water, so I'm not even going to touch it with my fingers. Okay, so there I see that the sodium, this time this is calcium, is similar to what the sodium was doing. It did sink, and you see that it's bubbling right away. Okay, this reaction is a little bit slower. It does not just sit on the surface, it will sink down, but you see that it is fizzing and bubbling as we go. Turning it very strong pink as we go, that should tell you what one of the products is going to be. Okay, so I want to know what type of reaction is this, and what is the product or products, and you can balance it. We're going to check in on this guy a little bit later because he's going to generate a little bit of heat, and as he does, that gets the reaction going even stronger. Now, the next one that we have is number 3, sodium chloride and silver nitrate. Just to speed this up, I've already put in your sodium chloride, and so I'm just going to add in some silver nitrate as we go. And we see evidence of a chemical reaction. What are the two products? The next one we see is silver nitrate. I've already put that in, and we're going to react it with calcium chloride this time. Okay, so the silver nitrate is in there. I'm adding my calcium chloride. Again, we see a very similar type of reaction. A different reactant, but we see the same type of product, at least visually. Next, we have our barium chloride, and that's what's in this test tube already, and we're going to add to this time sodium sulfate. Barium chloride's already in there. I'm adding my sodium sulfate. So you see a lot of times we're seeing this white cloudy stuff. This is a precipitate, okay? And so the question is, what precipitate is that forming? Next we have in here barium chloride, and this time I'm going to add not sodium sulfate, but this time I'm going to add magnesium sulfate. Again, we see the same type of reaction, okay? Different reactant, One of the reactants is the same, but different products in the end. Now, as I flip the sheet, we see that we have lead 2 nitrate in here. Okay, the Roman numeral tells me the charge of that lead. So lead 2 nitrate, and to this I'm going to add potassium iodide. So you see, not all precipitates are going to be white. This time we saw yellow. And if I was to let this sit, it would separate. The yellow stuff would be down here, and we'd have a clear liquid. So the question is, what is this precipitate? What is one of the products, and what do you think would be causing that yellow color? Checking in on my calcium. It's becoming a little bit more strong because it's adding some energy to it, and so it's picking up some steam as you go. And this is one of the dangerous things you have to know about chemistry, is how much energy is this given off, called an exothermic reaction, and that will actually serve as a catalyst to speed it up more and more and more. So a lot of people get surprised by their calcium experiments because it starts and it's nothing all that great, and then all of a sudden it keeps bubbling more and more and more, and it gets out of control. So learning chemistry at home is quite dangerous because it starts out very safe and cute, if you will, but then all of a sudden it starts to take off and people panic and they don't know what to do. All right, so enough of that sermonette. Let's take a look at number 8, which is ammonium chloride. Okay, that's in here, and to that we're going to be adding sodium hydroxide, which is a very strong base. Okay, you see that I had a little bit of phenolphthalein in here. Now, the question is, why didn't I see anything? Well, is a chemical reaction taking place? Is it getting hot? Am I seeing any vapors given off? Would I even be expecting some of those things? Okay. Next, we see that we have sodium carbonate and hydrochloric acid. Okay. So in the test tube is my sodium carbonate, and I'm going to add hydrochloric acid to it. Kind of a quick reaction, but you can see the bubbles. So the question is, what might those bubbles be? Look at your products and you should be able to figure that one out. Now, zinc plus hydrochloric acid. This is one that we've done before, but we're going to, I have in the bottom of this some zinc metal, and it's wet because I was just cleaning out some test tubes. So I'm going to add some hydrochloric acid to it. And this one we're actually seeing a vapor come out, and the bottom does get quite warm. Okay, now the next one is zinc again, and I kind of cheated because I let this sit for a while. This is one that's kind of a subtle reaction. If you take a look on the sides, we're seeing the zinc metal by itself, and inside is copper 2 sulfate. Again, the Roman numeral tells us what the actual charge of that copper was. Now if you look on the metal itself, you're starting to see some kind of reddish color. That's because there is a chemical reaction taking place, and I want to know what might that reddish stuff or orangish stuff be that's depositing on the copper or on the zinc. Why would that be? What kind of a reaction is this? Tell me what the products would be. What's going on in the test tube? All right, now the last one I've got is my magnesium metal, and we're going to be reacting that and burning it. Now, quick word on that because people always get confused at that point. When we say burning, what does that actually mean? Because fire is not an element on the periodic table. So when you have to burn something, what do you need? Well, we need to have a flame, and we need to have what? Because if you deprive a flame of this, then the fire goes out. Okay, that's about all I can give you for hints. What I'll do is I'll go off camera for a second because I have a burner in the background. I didn't want it near any of the gases that are being emitted. So I'll just dip my magnesium metal that looks like this, just a strip of metal, and it's kind of shiny. I'll put it into the flame real quick to get the reaction going, and there you see the reaction of magnesium metal that's being burned. Now, again, I got to emphasize, if you look on the periodic table, the fire itself is not an element. So what kind of a reaction is this? When you're burning something, what kind of reaction and what do you need? And notice that my magnesium metal has become this white powder. That's it for the reaction prediction lab.